Yes, I think it works. I think it works. I can hear myself as well because I'm always checking also on YouTube whether I'm able to see and hear myself. Hi, hello everyone again. Hello, Microbehunter here, all over here. And yes, we are ready to go for another Saturday microscopy live stream. I hope that this week's going to be a little bit less stressful than last week because last week I was struggling a little bit with my setup. Yeah, I do want to do a short follow-up at the beginning because I did improve the slide a little bit. But today what I would like to do is, I would like to show you those spacer rings. About 6 months ago, I already showed you those 3D printed spacer rings because I was making sand slides. Today I would like to make again a few crystals, okay, and I would like to mount them, make permanent mount of crystals, okay, and I would like to show this to you. And yeah, we're gonna, as every time, it's going to be slightly improvised because yeah, I've not, yeah, I'm just basically trying it out as I go along. And usually during the first couple of minutes, I would like to say hello all around the world. So I'm reading the chat here again. I have to switch this over to live chat. Okay, so hello from Lebanon, from Austria. Also hello from Austria. I'm right now in Upper Austria. Netherlands, hello from London. It works, that's good. Okay. Rhode Island, USA. Netherlands again, the UK. Texas, USA. From England. Okay, and from Northern Germany. Sound and vision is all okay. Yeah, and in case something goes wrong, if all of a sudden everything disappears, I'm offline, like already happened before, okay, then yeah, just I'm going to try to restart the live stream, and yeah, you might have to try a different link. If you have any questions, please feel free to post them in the comment section as always. And after approximately 1 hour, I'm going to try to answer the off-topic questions that you might have written as well. Okay, so let me quickly check again over here. Okay, we've got 26 people already who joined in. Usually around 1,000 people will end up watching the live stream afterwards because of the time difference across the world. Of course, it's not always the best time right now. Where I am right now, that's a Saturday evening, 9:30 in the evening. Yeah. So, and before I actually start doing those slides here, I would like to do a short follow-up of last week. Okay. Let me show this to you here as well. In case you joined me last week we did some galvanotaxis, so I put an electrical field on some paramecia, and basically this ultimately then did work, but it was a very unstable thing. So what I've done here is, I'm not going to try this out today, I'm still working on this, but maybe in one of the upcoming live streams I would like to show this to you. I'd just like to explain this, what I've made here. Yeah, here that's a microscope slide, of course, and look, now I've soldered 2 copper connectors. Maybe you know these things here. These are actually used to hold paper together, right? Made of copper. I soldered 2 wires on here. Over here I've got some cover glasses which are glued on using some nail polish, right? And over here, it's not completely hard yet. I stabilized everything with epoxy glue. Right, so this is basically much more stable. And then if you did not watch last week's live stream, you can always watch it, of course. This is basically the place where I would have put a sample with paramecia, and then a cover glass goes on top, and then the paramecia, they will actually move towards the negative pole, right? And that's simply something that I was able to, or attempted to show last week, and it kind of the parts fell off because it was not quite stable. But right now it's much better. Still not fully satisfied, so I keep on working on this. The reason why I'm not quite happy is because the glue, specifically the nail polish, starts to shrink. So there's some air bubbles in here. Air bubbles are not really a big problem, but some liquid might go in there, right? But for single use, it's still gonna work. Okay, so I'm going to, more people have joined in. Okay, and hello from Northern Germany. Okay, hello from Australia, York in Pennsylvania, from France, from Germany again. Okay, clear UV curing resin works great for these things since you can make it almost completely solid in just 30 seconds. That's actually an idea, and as a matter of fact, that's actually something thank you for the comment from Jesse. As a matter of fact, there's this nail polish, a nail gel, which is UV curing, which I actually have. I've got it over there. And actually, I didn't think about using that. And I've got a UV flashlight as well. So that's actually a thank you for the recommendation, and I will try that out, right? So that's basically something that I'm working on. So maybe in one of the upcoming live streams, I'm going to pick up on that again, okay? So yeah, and over here, something which didn't quite work as well. I also tried to glue the cover glasses here to make a spacer using epoxy, there are no bubbles in this case. It's a little bit thicker, but the problem is if epoxy starts to come out here on the side, it's difficult to remove using a sharp knife, and it ended up cracking the cover glass here. Here as well. The epoxy is so viscous that the cover glass cracks. Yeah. So I think there are easier ways to glue the cover glass on the slide. Yeah. Just wanted to show this to you as well. Yeah, just before we actually get started with the actual thing that I want to show you. Okay. Yeah, so this is basically, I think there are multiple possibilities here. So I'm going to show you now what I want to do today, and I hope that I'm going to be a little bit more successful than last week. Okay, so what I've got here is have you guessed? Some of you already know this is my coffee warmer. This coffee warmer is actually a hot plate, which I'm going to need, and I can turn it up all the way to 80 degrees. Okay, so I'm going to get it preheated now. Let me refocus this here, okay? And what I want to do is the following. I've got some chemicals over here, which were sent to me from a friend in Germany a few months ago. Again, if you're watching, thank you again. Yeah, so I've got some ascorbic acid, it's vitamin C. I've over here that's salicylic acid, which is aspirin. It's all labeled in German. It's tartaric acid, Leinsäure. I think it's called the same thing. It's aluminum sulfate, I think. It's allium in English. Then I've got some urea over here, and this is copper sulfate. Yeah, and what I will be doing is I want to dissolve those in. I want to dissolve those in a little bit of water, and then I would like to put a drop on here. On the spacer ring. I'm going to tell you a little bit more about those. I'll make the STL file for 3D printing available for you, of course. I think I cannot copy paste it into the chat, but later on into the comment section I'll put a link. Okay, and what I've done is the following, and here also semi-successful. Just want to tell you again a little bit of a problem, not a big problem really, but I used. Again, I'm going to focus again. I glued it, the spacer ring, also with some nail polish, and because the nail polish shrinks, there's only contact on some places. It's still good enough, but I think it still can be optimized a little bit. Just would like to tell you a little bit how those spacer rings are a little bit different. I redesigned them today in the morning. The reason why they're different from the previous one, so if you go back a couple of months when I did the sand slides, I also used those spacer rings, however they were much thicker. The spacer rings this time are only 0.5 millimeter in height. So I think the other ones that I used were 1.5 millimeters, so 3 times taller. This one is basically only 0.5 millimeter in height. And essentially, maybe you can see this, but there is this inset here to hold the cover glass, and which is a little bit lower. So the actual distance between the glass slide and the cover glass is 0.3 millimeters, 1/3 of a millimeter. So it's already quite narrow, but I hope, and I think it's still high enough to hold the crystals. Okay, I've made it a little bit more smaller for stability purposes. And so that I can also use a slightly higher magnification objective because the distance is not quite as high. So this is basically something that I have designed using Tinkercad, which is a free online tool, and then I 3D printed it. The layer height, for those of you who are in 3D printing, the first layer is 0.2 millimeters and all of the remaining layers are 0.1 millimeters, but essentially you can decide this yourself. So basically that's what I've been making. Look what I've got here. I've actually got a whole bag of them made. I printed over 20 of them at the same time. It really only took a couple of minutes to do that. Do they have to be round is the question. And the short answer is no, of course not. However, round ones do have basically, yeah, the advantage that there are no corners, and sometimes if the corners are not quite, and it's for stability purposes as well, I think round ones might be better. And I would say that probably it's more a question of aesthetics of yeah, it looks kind of nice. Yeah, but I think there's no reason why it should be round. Yeah? So if you, as a matter of fact, the square cover glasses are significantly cheaper. And why not? You know what? Thank you for the recommendation. I'll keep track of this. I'm going to make square spacers. Why not? Okay, and then yeah, because square microscope cover glasses are much more common and cheaper, right? But I simply use those because it kind of looks nice. Yeah. So basically, I've made 9 of them or so. Yeah, yeah, and I can show you actually how I use basically how I glued them on. Yeah, so I've got a whole bunch of those, and as a matter of fact, I have another bag over here as well. Yeah, and those here are for so basically they are for 18 millimeter diameter. Yeah, but I've also got some slightly larger round cover glasses for 20 millimeters in diameter. Yeah, and basically it's also how it looks like. Yeah, basically the same. Yeah, I think the thing that I just want to make clear as well is that the inside ring here. Basically, I don't know if you're able to see this. I have to show this to you. You see that it's kind of goes a little bit lower here because that's kind of where the cover glass is held in place. And I've given it a clearance of 0.5 millimeters. So I made it a little bit larger because not all cover glasses have the same diameter. And because when 3D printing, there's also a little bit of a tolerance. So I basically made it a little bit larger so that there is a slight, not a gap, but the cover glass does not have to be pressed in place, but it's kind of able to rest without much stress on here. And the idea is that I'm going to put a little bit of nail polish also on here, simply to glue on the cover glass. And then when everything is dry, then yeah, I'm going, maybe not today, maybe next time, like you can put it on a slide ringing table and then you can actually apply some more nail polish around it. Okay, but this can only be done after it's completely dry. What I'm going to do now is I'm just going to refocus everything here again and every now and then I'm going to read the comments here. Okay. Yeah, actually would like to do a dual stream with Oliver at some point. Honestly, I don't mind doing dual streams, but I only don't know yet exactly how I would do that. So maybe if we kind of are streaming at the same time somehow, maybe this is actually going to work out. Yeah. So that would be actually quite a possibility. I would like, yeah, I'd have to see how to do that. If someone is, what I could do in a dual stream is if somebody else is streaming, I could actually get a screen grab somehow and then kind of incorporate this in the stream, or we just basically do it in parallel. And the viewers just have 2 windows open. That's also maybe, yeah. So yeah, okay, I can help set up the technical side. Yeah, I've not done this yet. Okay, so I'd have to figure out how. Yeah, maybe you can contact me and email me and explain to me how we could do that. That would actually be quite fun. Okay, so what I'm going to do is yeah, I'm going to get started, and. Yeah, I guess we're just going to look what I made here. Oh my gosh. It's supposed to be a spatula to take out some of the samples. So we're going to get started somehow and I'm just going to use my pipette. And I just decided I'm going to put into those, these are basically Petri dishes. Yeah. And I'm going to just do the following. I'm going to put this in here. I've got some water. Look, that's one of the problems of this coffee heater. That it kind of there's this rubber thing on here, but it doesn't lie flat anymore. So maybe yeah, we just put it on here directly. It's also a possibility. It's very hot. Maybe that's a little exaggerated to go 80 degrees. So I think 55 might also be fine. Okay. So. Yep. Okay. Yeah. There are some off-topic comments which basically I will talk about later. Okay. So let's put this over here. I'm going to move all of the things a little bit to the side so I do not spill anything. And I'm just going to do the following. I don't know, maybe take a milliliter. The actual amount is not so critical. Yeah. Let's start off with an all-time favorite, which is, of course, ascorbic acid, which is, of course, vitamin C. Because this one really gives nice crystals if I'm able to open it. Here we go. Okay. You might always want to keep it closed because vitamin C likes to oxidize. Okay. And I've chosen, I hope I got them all correct, I've chosen those that dissolve well in water. And this one over here, of course, I want to clean again because I'm going to be reusing the same one. Let me quickly, yeah, clean it. And you know what, this ascorbic acid, let's put this over here. The next one would be, salicylic acid is not water soluble. I need some alcohol for this. Salicylic acid I'll do later then because the alcohol evaporates quickly. This one is also aluminum sulfate. I think just the second word is the ascorbic acid. Just a sec. Here it is. Okay, let me put this over here so that I know where it is. Okay, so let's. So this one over here, I put over here. This one over here is the next one. Should be enough. As it dries, the concentration changes anyway. Again, you have to wipe it. Tartaric acid. I don't know. Let's try those three first. And let's do the other three later. And of course, you're welcome to comment and ask questions. As I promised myself, I want to do it today a little bit more relaxed than last week because it nearly didn't work out what I wanted to demonstrate last week, and it really stressed me out a little bit. But that's a little bit in the nature of the whole thing here, right? So so I got those three over here. I need to simply prepare three slides. 1, 2, 3. 1, 2, and 3. And I'm going to wait again a little bit until it dissolved, and let's have a little look at the thing here. Okay, so far, why are all these substances white? This one isn't. Let's put it this way. Why is foam white and why are clouds white? Very often it is they're transparent, and however, because this is of course not just a crystal, a transparent crystal, but also intermixed with air, and because of the different refractive indexes between air and the crystal, which is transparent, it appears white because the light is fully reflected. It's a little bit like clouds, right? The clouds are made of microscopic water droplets. Water is transparent. Still, clouds appear white because the light bounces around because of the different refractive index between the air and the transparent water, and therefore the light is ultimately reflected, and therefore it appears to be white. Same as in foam. Foam is also actually water and air, right? And it also appears white. But some substances actually do have their own color as well. Yeah. So that's kind of the thing. And I actually do have others which are not white. And if you actually look at it, maybe you don't see it so quite well on YouTube. But this one actually is slightly yellowish. And as a matter of fact, vitamin C will turn more and more yellow and then brown as it oxidizes with the air. Okay. So you see that not everything is dissolved yet, but that's perfectly fine because... why is this fine? Because sometimes if there are some crystals remaining, then they can also act as crystallization seeds. So this basically is where the crystals continue to grow. Yeah? So yeah, if you have any questions for me, just please indicate at Oliver or at Microbehunter. Yeah, and that'll be fine. I have to label the slides as well. So I'm just gonna give you 1, 2, and 3. 1, 2, and 3, and I'm going to. I have a sheet of paper here where I would like to also put down the. So 1 is ascorbic vitamin C. Number 2 is alone. Number 3 is tartaric acid. Okay, simply that I know what it is. Otherwise, later on, I'm getting completely So let's give it a try. I don't know how much I'm supposed to use here. Let's use 100 milliliters maybe. I can't because it only goes up to 50. Yeah, let's see how much we're able. Yeah, and let's try to spread it a little bit. The issue is only that as the water evaporates, the drop might actually start to become smaller, and then the crystals will actually start to grow up into the air, which is sometimes then a little bit too thick. But we're just gonna give it a try. Okay, so here we go, and then we're gonna give it a couple of minutes, and then number 2. Doesn't have to touch the edges. It's a little bit, as always, it's a little bit an improvised thing, because usually when you want to do proper slides, you probably want to take your time. This is a little bit like all of those Saturday live stream microscopy videos. It's a little bit of a, how do you say, trial and error, a little bit of demonstration. One of the things that I've always found difficult, however, is the whole issue with surface tension, because in many cases the nicest crystals are formed when they're nice and flat, right? But sometimes the droplet will not stay nice and flat, but actually will start to pull together, as I just said. And this is then actually, so here we go. And what I'm going to do now is I'm just going to push those to the side again. We're going to have a look on how this actually works. So this is now 55 degrees. Usually it does. It's pretty hot already. There's in some crystals can also be, like, for example, citric acid. You can also try to melt it over a heat, but you have to be really careful that this doesn't destroy the crystals, because if they start to oxidize, then basically they won't crystallize out very nice. 100 microliters. This is a microliter pipette. It's actually those things. If you buy brand ones, they cost several. I mean, in the lab, when I worked in the lab, they were several €100 each. I think €300 just one pipette. This was significantly cheaper, I think around, I don't know, 20 or 30 euros. And so this one, you can adjust it over here. So probably it's not quite as maybe as accurate as the other ones, because the other ones are calibrated, specifically made for molecular biological laboratories. But for my purposes, it's perfectly fine. So as a matter of fact, if you go down with the thing here, let's say all the way to, I don't know, let's say 5 microliters, you can actually also pick up individual let's say tardigrades, individual cells, using the 5 microliter. It still takes a little bit of patience, but actually it's possible to actually pick up some organisms this way as well. So again, I think the actual amount that you put on the slide is not relevant. Oh, you see this one actually already started to crystallize. Not crystallize, but actually evaporate. And what I see here is I don't see any crystals yet, just yet. This can sometimes be the case if the concentration is not right. So if basically you do not see any crystals forming because maybe the concentration is too low, all you do is you add a little bit more. And I think maybe I'm just going to speed this up a little bit, going up a little bit Yeah, 10 degrees more. And in the meantime, if you flame the slides, the water flows apart better. Yep. Or maybe sometimes it also works to add a little bit of a small amount of a detergent like soap in it. But the problem is every time when you add some impurities, it might influence the crystallization, right? Yes, exactly. Dishwashing detergent. Yeah. So this is also something that I once tried, but you have to make sure that the amount is small. I also broke the surface tension by adding a little bit of alcohol. The problem with alcohol is if you add a little bit of alcohol is that the alcohol will evaporate first, and then again you have the surface tension of acting and the drop pulling together, right? So you see with this one over here, we're actually already kind of finished, but I don't see many crystals yet. But the funny thing is look what happened. Did I touch the paint here? The number. Let me write this here. Number 3. Okay. So and let's just try to put it under. I've got some polarization as well. So but I do not see any crystals. So I'm a little bit. Yeah, I think that we might not be able to see something yet. Here, oops, that's embarrassing. No, okay, I thought this was a diatom. It's not good. Because I washed the slides. Yeah, I washed the slides. See, there's some dust and dirt. And, oh, yes, we do see some crystals. Okay, lucky us. Here we go. Okay, and again, there is no cover glass on here yet. But it does look nice. At least we've got that. So now you know why I like these things, because you can actually take nice pictures and then you can get them printed out or developed, and then you can put them on your living room wall. Okay, so this is actually yeah, quite. Let's do it like this. Yes, now it's a little bit brighter. So here we go. Yeah, so here that's I would, yeah, this is now with the condenser in place. I've got DIC, so look what happens if I turn the DIC prism. Yeah, I can play around with that. No, you can just use regular linear polarizing filters for that as well. Also works fine. So at least we got something nice here. Okay, so that is number 3 is a tartaric acid. Yeah, and but I promised you that I wanted to make some permanent slides. It's not yet permanent. Now I will tell you why I've used those spacer rings here. Because I cannot put, or I do not want to put, a mounting medium on it. The reason is because some of the mounting medium might actually dissolve the crystals, and they might actually also change the difference in the refractive index between the crystals. Yeah, so we might not be able to see them anymore, because you see those structures best when they are surrounded by air. Look over here, maybe, I don't know. You see over here on the, let me point this to you. Where is my mouse? Over here it looks like it has not yet crystallized, and the crystals appear to be growing like this. So what I'm going to do is I'm going to really zoom in a little bit more. I hope that the distance is going to work. Up. Yes. Let's see if we're able to see them grow. You know what? I'm going to keep the arrow. Let's put it right here in the corner. Yeah, I don't know. Oh, it becomes smaller. What's going on here? Ooh, the crystal is melting. Do you actually see that? I have a fear. And I think I know why this is the case. Look at this. Isn't it interesting? It's melting. Why is it melting? And I think look, did you just see that? Yeah? Look. This one over here. Over here. Look, it's becoming smaller. It's melting. And I have a suspicion why this is the case. This shouldn't be, and that actually is a very nice demonstration why you probably want to make, why you want to put a cover glass on top here. Look, here it's also melting. And I think the reason why this happens is because of the moisture in the air, right? And I think maybe, yeah, it attracts the moisture in the air and therefore it starts to, yeah, dissolve again. So by actually putting a cover glass on top and by making sure it's really sealed off, maybe we can make this a little bit more permanent. Yeah. Yeah, they're hygroscopic. Yeah. So basically, because of the heat that I had before, this actually caused the water to evaporate. So if I put it back here again, yeah, then yeah, we should have the crystal reforming. But let's try number 2, which is this aluminum. Okay. I'm waiting a little bit. Ah, yeah, just a second. You probably want to see the desk here. Okay. Here it is. I do not see any, but look at the vitamin C. The vitamin C looks very white now, so there are really a lot of crystals here. You know what? I'm going to turn this down now. Yeah, it's still quite, I don't know, this is 65. It feels hotter than that. I don't trust this temperature setting so much. Yeah, let's make this a little colder. Let's put it on a colder surface. Let's put it on here. And let's see if we're able to see something here. Scope. Here we go. No, nothing here. Let's go down with the magnification. So for whatever reason, I'm not seeing anything over here yet. Okay, so maybe it does take a little bit more time, or maybe you have to go. I have to go up with the concentration, but I don't think so because there is actually something here. So what I'm going to try now is the following. I'm going to try to actually seed it a little bit. How do I do that? Yeah, either it's not completely dry yet, but if you put a small crystal on here, maybe it will start the crystallization process. So that could be, yeah, this is kind of clean again. Let's try to seed it. I don't know if I've seen anything. Yep, let's have a look here. So, yeah. Here it is. And maybe, I don't know, if we're lucky, we're able to see the crystallization process continue from there. Might take a little bit of time, but usually it's crystallizing quite well. Huh? I'm going to have a look again. Yeah, there's some general comments here. Yeah. So I don't know how well this is actually going to work. If not, I'm going to just give it a little bit more time. And then let's hope for the best later on. But normally this should actually be an easy one to crystallize. But maybe it simply, yeah, maybe it simply takes time. Okay, now let's have a look at the vitamin C. Let me just check a little bit again. Let me put it back again. Here we go again. You see, those crystals here actually are in contact with the liquid. I'm going to try something else. I'm going to try to... Let's wait a little bit, and let's see if the crystallization starts. Okay. That's again one of those demonstration effects because the last time actually did work quite well, but I'm going to just put it here on the side and let's have now look at vitamin C. This one should be an easy one. Yeah, of course. Yeah. So that is vitamin C. I've seen actually nicer ones before already. Yeah. But what you see over here on the side, that is, when it's so dark, that is actually a sign that the crystals are very thick. Okay, and they have started to grow up a little bit into the air, into space. And those crystals here are much thinner. Yeah. And sometimes you are able to also see how they basically start to grow. But sometimes what will happen is that the dissolved material substance will start to form a crystal here right on the edge, and it will deplete the concentration of the substance here in the center in the liquid. And therefore the crystallization will stop because there's simply none of the substance left. Yeah. So this is actually something that can be observed also quite often, that all of a sudden it stops, but the reason is the crystallization stops because there's simply no more substance left, because all of it has crystallized. Yeah. So so this is basically the thing here, and what I'm going to do now is I'm going to have another look at the this one over here, the one from the tartaric acid, the one that started to dissolve. Here again are our crystals, and you see that there is not much liquid visible. So what I'm going to try now is I'm going to try to put a cover glass on those, right? At least on those two here. And the other one over here doesn't seem to crystallize yet. Yeah. That's kind of interesting. Yeah. I'll give it a few more minutes, okay? But let's try to do the following now. Let's try to... Yeah, I still have a few left over here, but let's try to... How do you call this? Put a cover glass on those. So how are we going to do that? This one is... I need a cover glass and I need some nail polish. And this is now where we need a lot of patience. So where is the cover glass? So here, these are 18 millimeter cover glasses. And yeah, I want to take one of these here. I have to clean it a little bit because there's always this residue on it where I don't know what it is. But from the manufacturing process, rarely are the cover glasses completely clean. Using paper towel or paper tissue paper is not recommended because it's going to leave behind those fibers. Yeah. So let's give it a try here, and that's now where I need my. I just realized I forgot. Yeah. I need glasses, which I don't have here. So I'm going to try it without glasses. And what I have to do. I'm going to not put something around the whole rim here. I found this is going to be a little bit too, how do you say, difficult to do. I'm just going to glue it on a few places. And after the glue has dried, you can try to put a ring around it to seal everything off completely. I'm going to hold it up again so to make this a little bit bigger. Yep. Yes, now it's kind of locked in place. Yeah. Yeah, it should lock into place because it's a little bit lower than the others, but sometimes there is a little bit of a tolerance here, but you can actually see that it makes good contact on the side. So I think I'm just going to leave it as it is and allow it to simply dry. Yeah. So that's number one. Number two. Let me try it without nail polish first, whether it actually locks in place. No. What's the problem? Did I get the... Up! Nothing happened. Just a second. Did I get the right side of the cover glass or did I accidentally glue on the wrong? What in the world? Just a second. What diameter does this have? Don't tell me that I actually glued on the wrong size here. Ah, these are 20 millimeters ones. I got the wrong, where are my 18 millimeter? Oh, okay, my bad. There was a larger cover glass in here. Then I accidentally mixed the cover glasses. Okay, here, that's the smaller one. That's good. Because I was wondering already why I didn't, yeah. There were two larger ones in this container. That's why it didn't fit. And here we go again. Let me try it. Yes, this one locks into place. Okay, good. So what I'm going to do therefore is I'm going to put again a little bit of just on 2 or 3 places. And here we go. The problem is I don't have my glasses with me. Yes, no, it didn't. Here we go. So what do I learn from this? So maybe I should make the rim a little bit higher on the side. Yes, but now it locked. Now it's in, I think. Yeah, okay, so that means I will modify those rings a little bit and make them a little bit taller. Put this on here. Yeah, it's in. It cannot escape. Or did it? I think I'm just going to let the glue, the nail polish do its job. Yeah, it's in here. Okay, so that's the next one. And number 3, and this one was number 2, which was this one over here, which still didn't, yeah, for whatever reason, still didn't crystallize out. I'm just going to wait a little bit longer. Okay, so let's move now on to the, yeah, that's okay. Let's move on now on to the next one. Let me check the other one here. Did I also use the larger one here? I think it should be okay. Huh? No, did I use the larger one over here as well? I think I also used the larger one here. Ah, okay. Yeah. So let's move on and let's try, yeah, the remaining 3 here. This one is urea. And let's put the other cover glasses away. And urea and copper sulfate. Where is my thing here? So and where is this here? Let me clean off the spatula again. So you also want to make sure that it's completely dry. Okay. I'm going to add a little bit more now to increase the concentration a bit. So this is the next one. So, and this one is an easy one. That's urea. I don't remember. Yeah, and urea. So that's number 4. And number 5. Usually, just for your info, when I really want to make nice pictures or nice slides, usually I make about 20 or 30 of them, using different concentrations and different temperatures and so on. And then I'm just going to select the nicest ones, right? I cannot do that now, obviously. Otherwise, I would have 20 or 30 slides. It would take also too much time. So the point here is simply to illustrate a little bit of the kind of the proof of concept, so to say. Yeah. So let me quickly check here again. Okay. Yeah. So there are no further questions that I see now. Okay, good. Okay. So let's give it a try here again. So let's put those away. Over here, I'm going to go up with a temperature again. And let's give it a try. Number 4 and number 5. I'm just going to apply it directly on here on the hot plate. Number 4 is copper sulfate. Let me quickly write this down as well. So for number 5 is urea. By the way, urea was the first organic, artificially synthesized organic compound. So let's take another pipette tip. And let's try the copper sulfate now. Not everything has dissolved yet, but that's fine. Maybe there's some remaining crystals left over. So number 1. And urea number 2. And just again a couple of minutes. And let's be again a little bit patient here. Late entry, hello all. Yes. Dimitris just texted. Basically what I'm doing today is I'm doing again some of the crystal slides, and I'm trying to attempt now to put some a cover glass on top here, because putting mounting medium on a microscope on crystals is not going to work well. So here number 2, yeah, we have not seen any success yet. So what I'm going to try is I'm going to simply try to increase the concentration here by adding more of this on here. Ah, yeah, so this one here, yeah, slowly starting to dry out. Number 2 here as well. And not all crystals are equally easy to crystallize. Sometimes, yeah, it simply takes more time, and maybe a lower temperature would be better. But because of the live stream, it's of course we're a little bit time restricted. Okay, so I'm gonna wait again a few minutes. Let me quickly check. And yep, I was just simply checking a little bit on also the time delay. I'm now in my YouTube channel. There are about 5 seconds delay. That's fine. So, yeah. Look over here, number 4. That's the copper sulfate. You see there is, yeah, something forming already. Would sugar or salt also make nice crystals? Yes, however, sugar and salt are not necessarily always nicely polarizing. So for example, if you do salt crystals, actually I could have, that's actually an easy one to try. I don't have salt with me now, but generally salt crystals, yeah, they look much more square, right? But in polarized light, other crystals actually give more color. Yeah? And regular salt is not polarizing, and therefore you are able to see the crystals, but it's not quite as colorful. Yeah. So let's try this one over here. That's copper sulfate. So I need to change now to the scope view again. Yeah, here that's the ring, and here we are. The crystals seem to be much smaller and they're quite dense. Okay. Yeah, let's go up yet further. Yeah, actually also quite nice looking. Yeah, so the crystals are significantly smaller, so I can imagine that at a different temperature. Here it's quite thick again. Yep. So yeah, by kind of changing the temperature, you can also change the crystallization speed. And I can imagine that maybe if it's too hot, maybe you've got many smaller crystals forming. Yep. So, but yeah, here we go again. That's how it looks like. So we can put this on the side, also for cover glass. And where is the desk view again? So the aluminum one does not seem to like to crystallize. So that's a little bit of an issue here. And number 5, which is urea. Let me see if there is something happening here. Let me also cool this down first. And the scope view. Yep. And these are urea crystals. There's still something happening here. Yeah. Crystallization is still in process. It's almost like fractal geometry here, what we see. Yeah. So, yeah, here. Of course, it's also possible, and I've done this also in previous videos already, to actually, if you have the time, to observe the actual crystallization process directly live under the microscope. However, yeah, it depends very much on the ambient temperature, and sometimes this can take quite a bit of time. And for this reason, I'm just using the hot coffee warmer that I have. I think that is also quite nice looking. Okay, so. And the aluminum sulfate, I don't know, there seems to be also something happening a little bit. I'm not quite sure. Yeah, I think I have to. So what I'm going to do now is I'm just going to put a cover glass on those here to kind of get those a little bit more protected. Let me see. Where is the desk view? Here we go. Here we go. I need the smaller cover glasses. Yeah, and I'll try to do the following. I'll try to get some spaces for the square. What I've done in the past also, I used those, I tried to punch out those spacer rings from, let's say, plastic or cardboard. Cardboard was not so successful. The reason being that it was so absorbing that it did not stick to the surface of the slide. And I also do not fully trust those yet. So what I actually will do is on the slide ringing table to place there to ring it, and probably also to apply a little bit of nail polish or glue also on the side here to kind of go beneath the ring a little bit more to stabilize it more. Because nail polish, again, even though it's been commonly used, has the issue that it does shrink quite a bit, and therefore might not always make very good contact. So number 1, and up. This is very again, I should have taken my reading glasses. Did I get the wrong cover glasses again? Don't tell me. Let me see. These are the smaller ones here. I think I actually... Okay. Never mix cover glasses. I think they're smaller. And do they lock in place? Yes. I've given this a tolerance of 0.5 millimeters. But some cover glasses are not quite entirely round. So this basically means that, okay, that I might have to add a little bit more tolerance, or I have to check. Yeah, now this one is locked in place. Just a second. Yeah. And let's try the other one here. You know what I'm going to do is I'm going to try it before actually putting it in. I might have to give it a little yet more tolerance on the side. But I've seen, I don't know if you're able to see this, but sometimes the cover glasses are not entirely round, but they have a little edge of, outwards, and this can prevent it from actually snapping into place. So a little more here. So number one, number two. Yes. Okay, yes. Okay, so basically this is kind of the idea, how it would work. And I'm still wondering about this one over here, which just refuses to crystallize. There is a little bit here, so let's have a look. I don't know if this was enough or not. Where is this? The scope view. Okay. Ah, yeah. That's interesting. It looks amorphous, strangely enough. Ah, yeah, there's some. My questions are arriving. Thank you very much. Okay, here they are. Ah, yeah, a few of them. Yep. So, yeah, look, this is kind of interesting, really. If you look over here, you can actually see so it looks almost amorphous a little bit. Also, the bubbles over in here, but so for whatever reason, it doesn't crystallize. It's quite fascinating. Maybe not enough crystallization seeds, I don't know. Yeah, over here, there are some of these original crystals present. Yeah, maybe it just takes more time for this to crystallize. I don't know. Which actually is a surprise, because in the past I was able to crystallize it fairly quickly. Yeah. So let's try a last one. Yeah, that's also something of a demonstration. Let's try the last one, which is basically, where's this? Yeah, that's basically aspirin. And the aspirin I have to put into alcohol, because otherwise it's not going to dissolve. So again, a new desk view here. And let's put those here away. And over here, a little bit of alcohol. Okay, here we go. And where is the aspirin? Yeah, it's a lot. But you can see that it dissolves really well and quickly. The air quickly bubbled out. And this one should not be an issue concerning the surface tension, because of course alcohol has a very low surface tension. You can still see that some of the aspirin did not dissolve, which is also fine. So, let's give this here a try again. And bloop. You see it spreads very quickly. If we put it on the hot plate, then the alcohol should dissolve, evaporate rapid. Oh my gosh, I'm pushing the... Oh, we're already finished. This was so quick. Okay, look what happened here. That's actually quite interesting. I'm gonna show you. This is basically aspirin. Look, there is there are also crystals forming on the outside here, and the reason is because the ring was not it contained some gaps, and so the alcohol was able to flow beneath the ring. Yeah, basically you can also see it over here. You see that because of the shrinking of the nail polish, there were some air spaces here. Not ideal, but this is how the alcohol was able to escape. Yeah. So let's put this under the microscope now. Scope view again. And here we go. Yeah, so you see that. Yeah, also looks... You can actually see at the point where crystallization started. Yeah, and then it continued to spread out from there. Yeah, usually start over here and then kind of like a I don't know, fanned out, so to say. Yeah. So yeah, so that's basically an advantage of having substances being dissolved in alcohol, because it's simply so fast, the evaporation. So caffeine, for example, for those of you who watched my previous videos as well, also dissolves well in alcohol. Yeah, so this is basically where the crystallization process started. Yeah. Yeah. I think crystallization works much better if the liquid is at or very near saturation. Yes, the thing is the following: when the water evaporates, then actually it will go into saturation. Yeah, so that is so it's going to reach a saturation point in any case. However, it is like this: the challenge is how do you actually keep the drop spread apart so that over here, how do you actually keep the drop spread apart so that essentially it does not pull together and start forming crystals upwards? So I found again the nicest crystals are those that are flat on the microscope slide. So how do you actually prevent the water from forming the surface tension of the water from forming actually a droplet? Yeah. So this is a little bit, so maybe a little bit of detergent, or what I've also sometimes seen is that if there is a little bit of dirt, as a matter of fact, like dirt, I mean, let's say calcium carbonate, because from the water on here, sometimes this actually also helps the drop to be kind of spread apart more. So so this is kind of the alcohol, the one with the alcohol here. Okay, and here again I'm going to try to put a cover glass on top, but I already see that I probably have to redesign those rings a little bit, and I'm going to give them a little bit more tolerance. Yeah, because I think I've already made it 5 millimeters larger. Yeah, basically the inset than the diameter of the cover glass. However, because of the 3D printing, let me see, because of the 3D printing, the plastic, the PLA plastic also expands a little bit. Okay. So. I think it's a little too tight. It's interesting, yeah, because some of them actually worked quite well, and now some of them do appear to be slightly too large, but it seems to go in here as well. Yep. Okay, and now you just have to wait for the. But I slid it out. Okay, so. Yep, now it's snapped in. Okay. Yep. Yeah. And when it's snapped in, it cannot be moved anymore because there's a rim on the side. Yeah. So that's a little bit the idea. And then when this is dried, I left enough space up here to actually apply some more nail polish on the side here, and then it will kind of soak in and hopefully then really properly attach the cover glass to the plastic spacer. Okay, so this is a little bit the idea. And where is number 2? Number 2, still not crystallized. Really interesting. You know what? I'm going to. What happens if I? But it's really. It's actually quite solid. It's quite hard, but it's amorphous. It's not crystalline. Maybe I evaporated the water so quickly that it did not have time to actually become crystalline. That's interesting. Interesting. Okay, well, in any case, yeah, so this is kind of the thing that I wanted to show you now a little bit, this is also one of the disadvantages here. Okay, so back works again. Okay, so yeah, so in summary, I'm going to test this. In summary, problem was a little bit that even though I applied a lot of glue, that yeah, because of the shrinkage, there is not always a very good contact, so it actually might be easily removable. Well, actually, it's quite okay. This one here is quite stable. Oh, thank you very much for your generous support. Okay, thank you very much. Yes, I'm going to. I'm thinking about ordering again a whole batch of antique slides. Also because of last week's donations, so it's not enough money again back together to order the next batch. Might take a week or two for them to arrive. So thank you very much. Okay, I'll have a look at yeah, if I'm able to find again something interesting. Yeah, so yeah, it seems to be fairly stable. Okay, nevertheless. Yeah. So that is general problems that I had with 3D printing. If you want to try this yourself, where did I put them? Just a second. Where did I put the little? Here, hidden over here. Just wanted to show you a little bit some of the challenges that I had because I actually had to spend several hours today in the morning. Yeah. The thing is because they're so thin, they're not entirely stable all the time, and I just want to show you a little bit here. This focus, yeah, that sometimes the layer, yeah, it separates a little bit, yeah. So when printing this, you have to really make sure that, yeah. You have to get all of the parameters properly adjusted because it's not always very stable. However, it doesn't really have to be, because when you apply the nail polish or the glue on here, it's going to hold everything together anyway. Yeah, but that is essentially one of the things that I was kind of struggling with because there are only 1 or 2 layers here, and of course the different layers, yeah, they do not hold together then quite as well. Okay, so that was one of the difficulties here. That I had when printing those, and because they're quite a bit thinner as well as the previous ones that I made for the sand samples. Okay, yeah, and yeah, basically the idea is yeah, if you joined late, I'm not able to put mounting medium on those, yeah, at least not water soluble mounting medium on those, because the mounting medium might actually dissolve the the crystals again. Okay, so what time is it? Ooh, 1 hour 10 minutes already. So there are a couple of questions that I would like to ask in every week. I would like to talk about. So I need to clean up everything here again to make a little bit more space. Let me also turn off this one over here. There are a couple of questions here. Okay, I 3D printed some filters with clear PLA and it's clear enough to color in and used for all sorts of effects. So basically, I get it. Just a second. This refers to, it's out of focus. This refers to microscope filters. And it's possible to print microscope filters with a 3D printer. I've done this as well, but here is the suggestion now that you can use actually transparent or clear plastic and then use different colors, maybe some, I don't know, maybe markers or so to color it in. That's interesting. Thank you for the recommendation. I already mentioned this. Why all these substances are white? Generally, substances are white because of the total reflection of light, because of the different refractive indices between the crystals and the air. What is the function of the black ring? Okay, yes, the function of the black ring is a spacer, which basically holds the cover glass above the object, and the idea is to make sure that there is for the cover glass for protection, of course, and also to prevent moisture from reaching the crystals. Basically, it is a spacer because if you do not have this, then there is no possibility for you to actually attach a cover glass. If you want to, I don't have, now I only have clear. I'm just going to demonstrate this now. I'm going to sacrifice one of my slides for this very purpose. If you want to directly put a cover glass on a slide, it's not going to work simply by putting glue, or in this case nail polish, on the edges. I just want to show this to you. So if you want to basically put only some glue on the edges here and then kind of hope that you're able to glue it on the microscope slide this way. Okay, I'm just gonna show you what's gonna happen if I drop it on here, right? What's going to happen is that essentially, okay, I don't know if you're able to see this. Let me hold this a little bit. Yeah, you're going to see that actually it's going to be soaked in, right? And it's going to contact whatever you've got in the center here. So it's going to contact the crystals. And because these crystals can dissolve in some mounting media, for this reason, you somehow have to find a way of actually connecting a cover glass to the slide without the cover glass actually touching the crystals and without the glue touching the crystals, right? And you see over here, you can see that it already, carefully here, it has already reached almost half of, even though I only put the glue on the side, the nail polish on the side, it now basically already reached about half of the cover glass here. Right, so this is basically this with the spacer ring is kind of like a workaround. And as I said before, about 6 months ago, I made a video where I used this so for actually mounting sand samples. So basically, I used slightly thicker spacers, and then I added sand in here, and then put a cover glass on top. Yeah, so this was kind of the idea. And these spacers are 3D printed, but in the past I've also punched them out using hole punches, or I tried to cut them out. But I found that cardboard does not work well because cardboard is too absorbent, and then the nail polish or whatever glue you use will be immediately absorbed, and then it will not stick to the glass slide very well. So that's a little bit one of the problems that I found with other materials. I suppose that you need to let it crystallize first before you put on the cover glass. Yes, because if it doesn't crystallize first, now if you put the cover glass on top first, then the moisture cannot escape. Yeah, so it won't crystallize. So that's the thing. You have to make sure that the water is able to escape then the crystallization, then you put the cover glass on top. I use a contact lens suction cup to pick up and place on the... Lots of good ideas. A contact lens suction cup. I've got those. I've got. I don't know where I put them because I've got contact lenses, but that's actually a nice way to pick up cover glasses. Yeah, I'm gonna look for those because I bought myself several of those contact lens suction cups, which I ended up not using because I just take out my contact lenses with my fingers, right? But actually, it's a good idea. Would sugar or salt also make nice crystals? Yes, salt crystallizes very easily, but without colors in polarized light, but you still can try it out. And sugar takes a long time to crystallize. Some sugars are also very hygroscopic. They also absorb a lot of moisture, and therefore it can take quite a long time to crystallize. Yeah? PVA glue is used in book binding. You might use it to glue the paper board to the slide. Okay, I have not used a PVA glue yet. The reason why in this case it might actually work. The reason why I used nail polish here is because the PVA glue is water soluble, and I was kind of worried, maybe not justified. I was kind of worried that if I have now some water basically contacting now the PVA glue, that it might dissolve a little bit the glue, but we've already seen before, or I think in the previous last week's video, it's been said that once PVA glue is dry, it doesn't dissolve so easily anymore. Yeah, so that means evidently there's some kind of a reaction happening so that it doesn't dissolve anymore once it's dry. Yeah, so this is actually another thing that I might, I'm going to try out, and I'm going to report back. Yeah. So bottom line for today is the following: what I have learned. Try alternative, try different glues, not just nail polish. Number two, optimize the size a little bit here because I've seen that not all of the cover glasses fit into the rim quite nicely. Yeah, even though I made it 0.5 millimeter larger, not all cover glasses are actually the same size. And another thing that I learned is that some substances, interestingly enough, don't really like to crystallize. Like, for example, this one over here. Yeah, alum. Okay, that is the one normally crystallizes quite easily, but I suppose that maybe because I made it too warm, that the water evaporated faster than it was able to crystallize. So it stayed amorphous. It's completely dry. It's hard, but no crystals. So also quite interesting. Yeah. Use a Crichton and cut the rings from self-adhesive vinyl. Self-adhesive vinyl. That's interesting. Thin polyester film may be easily cut as a containing square frame. Should be easy to glue and will remain flat. Thin polyester film. I've not tried that. Okay. Yeah, but that could also be something. Polyester film. That might be something to try. I've also tried to use spacers if you, for example, credit cards. Old credit cards or plastic cards, then that you kind of maybe punch out. That's also possible. I've tried those as well, but I found out that during the cutting or the punching process, they kind of warp a little bit, and then they're not completely flat anymore. Maybe not a big problem either, because then during the drying process, you simply have to press it down. You have to clamp it down maybe, and then maybe it's going to be pressed flat again, and then flat again, and then it should be again. Not a problem. Okay. So what time is it? We still have a couple of minutes time, because I know that some people, I don't know, unless you have some questions, otherwise I would make a very big jump in topic, because I know that some people are more interested in looking at living things than at non-living crystals. I decided I'm going to check for the last couple of minutes very briefly on my, how do you say this, on my sample of paramecia again, and just to check if they develop nicely, because I need them in order to test them for this chamber that I made, which I'm still working on. Okay, remember this one that I showed you at the beginning? So for galvanotaxis, to see if they're actually moving in an electrical field, I need a lot of paramecia. And also, there was a request from one of my co-workers in school, because she wants to show some paramecia to her students as well. That's why I've also grown a few of those. For those of you who were not here last time, those white things that you see here, these are wheat grains that I dropped in here, and I left them in here for a week or so. And I pick out one of them. And let's see, maybe another one over here. And this one I have to disinfect. It's pointy, and if I hurt myself, I do not want to get an infection. Here we go, alcohol does the trick. And over here I'm going to put on a cover glass. And let's have a look. Just for those of you who are really eager to see some living things, because I do get some comments or so, people who actually prefer to see movement and living things. So let's have a look if they are fine. And I need to get the scope view again. Yeah. Okay, well, we've got some paramecia. Let me focus. Good. They seem to be growing happily. Okay. Yeah, I've got a nice culture of paramecia here. Let me try. Okay, I think we've got enough of these guys. Actually, quite a few. Yeah, usually it takes around 5 days to a week for them to actually grow from a water sample, because again, I received a comment, actually way more than last week, where people were checking water samples and were not able to find them. And basically you have to enrich them by actually growing them and reproducing them. Yeah. Can you use well slides instead of the rings? That was a question. I do have some well slides as well. And the short answer would be they're expensive. So that is a little bit the thing. Those concave slides are more expensive, and sometimes the distance is too small, I would say, because on the sides the distance is small, then it becomes deeper, and then again smaller. So it could be that maybe if something crystallizes on the side, that essentially the cover glass won't be entirely flat there, right? So I would say it depends a little bit on the on the thickness of the specimen. The well slides are definitely too not deep enough for sand samples, and actually I wanted to have a significantly cheaper solution than those weld slides. Yeah, so that's yeah. But I can imagine that for some applications they might also work. Yeah, yeah. Just wanted to show you again. But by the way, some people were asking, what do you do if they're moving away too quickly? And I'm just saying, then you just make sure that yeah, they are basically limited in their movement by not using too much water. Yeah, but still, they are still able to move around fairly easily, but they're already compressed flat a little bit. Yeah. So if I were to wait now for a couple of more minutes, then yeah, more and more water would evaporate, and then their movement would be limited yet more. Yeah. But maybe we can find this guy here in the center. That's a nice one. Let's go for this guy. Yeah. Because then we can actually look into the cell much better. Here we go. Yeah. And yeah. All of the cell organelles, and yeah, this guy is caught now in his own food, so to say. Yeah. Yeah. So that is yeah, I would say, unless you have more questions, yeah, just another thing that I just want to mention for the last couple of minutes before I stop. You've probably already seen me. Some of you are basically joining in pretty much every week, more or less to the live streams. But of course, occasionally I make some YouTube shorts, and also maybe about once a week or so, one or other video as well. I would like to know a little bit more what you guys are interested in, because for me it really doesn't make a huge difference, and the biggest difficulty of making YouTube videos is not actually making the video, but actually thinking of topics, right? So I've been thinking also of going a little bit, maybe, broadening up a little bit, and also talking about related biology topics, maybe some biology theory. I don't really know what the community is interested in. For this reason, if you have any recommendations, please feel free to communicate them to me. Because I've seen also by looking at the statistics of this channel that, and that's quite nice. I've got a kind of a core community that always kind of keeps on coming back, but it's more difficult to get more people involved here, right? Because microscopy and the stuff that I'm doing is kind of very niche already. It's very specific. So it does not have this broad general appeal as maybe other topics have. So if there are anything specific that you're interested in, right, then please do feel free. So this is a common question. How do you get the different colors on the same background? So basically, how do I do this, right? That's some of the reason is that I have got a contrasting technique called DIC. It's called DIC, differential interference contrast. This is something that most microscopes don't have. It's also it's not the cheapest either. And not a lot of companies offer this. That's kind of the reason why I've got it, is because if I want to show videos under, colors are always nice, right? In bright field, that's basically how most of you would actually be able to see it. It's also okay. So if you want to get colors, then you're probably going to work with color filters. So there are quite a few possibilities to add more color here as well. But in my case, I can do something like this here. And change the color around as well, simply to keep everything a little more interesting. I really like the experimental view. Maybe make some videos on what you are working on. Doesn't matter if it currently does not work properly. It's always inspiring to see. Okay, thank you. It's always one of my worries. Sometimes I show things and they don't always work the way I hope them to work. Like, for example, the crystallization, which didn't work here in this one substance. Usually, while I was still working in the lab, I've got a degree in microbiology. Long time ago. Now I'm teaching. I went into education, but when I was still working in the lab in microbiology, I would say that the majority of the experiments did not work out. Maybe 2/3 of the experiments did not work out on the first try. The reason is because you always had to optimize something. Until you actually got a result. So this is actually something which is normal to a certain extent, can be quite frustrating as well. But I've known people who essentially spent weeks, if not months, trying to optimize something, and then it still didn't work. So that's simply part of it's a little bit tedious, the whole thing. So in that sense, I'm used to that. So that is the thing here. This paramecium is trying to escape here. Let's see. Usually, what happens is that they will move to a place where there is more oxygen. Here, that's again the bright field view. So, and I'm happy to say that we've got plenty of paramecia here. Okay, so I can experiment around again. Look, there are lots of them. If you joined in last week, you remember? There were just a handful of them. Now they've really reproduced quite a bit. That's a ton, look. Very nice. Okay, I think we've got a good basis. I've got a good basis now to continue my experiments with this electrotaxis, galvanotaxis as it's called. What's your favorite ciliate? Oh, gee, I wonder if I have one. Um, Basically, I don't have a favorite one, but those paramecia are, as model organisms, quite interesting. They're fairly large. They're single celled, and it's somehow, because they're so easy to keep, I kind of always keep on returning to them. But I would say they're more interesting ones. Lacrimaria, I think, is a very fun one to look at. It has this long swan-like neck, pretty aggressive. It's kind of searching around, and then it's, yeah, using its neck and attacking other microbes and eating them. It's kind of more interesting to observe. So maybe Lacrimaria is one of my favorite ones. Huh? Is there a way to count them? Well, what you want to do is you want to actually take want to make a density measurement, right? So you want to see how many of them are there in a certain volume. And yes, there is a way to count them. What you have to do is you have to put a defined volume under the microscope slide. There are so-called counting chambers called hemocytometers available. So actually for counting red blood cells. The problem with those ciliates is that they essentially they always keep on moving around. So what you probably would do is you would probably take a picture and then count them on the picture, right? So that's essentially a possibility. But there are thousands, hundreds, thousands of them in the sample. Yeah. As a matter of fact, you can even see them without the microscope as tiny moving dots, especially when the light is correct and when it reflects the light properly. You can actually see those dots moving around on a microscope slide. So yes, you can see them even without a microscope. I think you might not be able to see them here. You might not be able to. No, the reflection isn't. No, maybe. Yeah, you can. Maybe you can actually see them. Maybe is there dark? You know what? I'm gonna use this as this. Yeah, look. Yeah. Do you see those tiny moving dots here? Yeah, you should actually, even in YouTube, you should be able to see that now. I know that in YouTube you always lose a little bit of image quality, but there are those tiny dots moving around. Yeah. Last experiment. I'm going to quickly show them to you under the stereo microscope. Yeah. Or I need to. You see, not the contrast is simply not good enough. Yeah, that's in the stereo microscope with light coming from the top. No, contrast not good enough. And with light coming from the bottom, I have to switch on the light from the bottom. I think we also might not be able to see it. Nope. Contrast simply not good enough. Nope. Let me focus the edge of the cover glass first. Yeah, here they are. Okay, so that's basically now with light from the bottom, yeah, using a stereo microscope. So you see, it's not the magnification that's a problem here with a stereo microscope, yeah. It's more a problem of lack of contrast, yeah. So when people ask me, can you see paramecia using a stereo microscope? Yeah, you can see them, but it's not really ideal, right? So last comment, one of the things that I also would like to try is the following. And that is, I just also inform you a little bit of what I've done here is, and then I'm really gonna call it quits because it's 1.5 hours already. Ooh, okay, over. I've essentially added some yeast in here, and not a wheat grain, but some yeast. And I kind of hope that this is also going to work. I just put this, set this up the day before yesterday. So I'm just testing out whether I'm also able to grow them to high concentrations using yeast, and whether they like to eat that as well. Okay. Yeah, that's basically stuff that I'm experimenting around with. Huh? So I think enough for today. Here they are again, what we prepared today. I think I'm going to again leave it at that. A magnifying glass might work even better than a stereo microscope. Yeah. So it's microscopic life in my aquarium. Scratch some algae off the insides window of the aquarium, and then you might be able to see quite a bit of things. Yeah. Okay, I'm going to leave it at that. I'm going to think again of a topic for next week, and maybe I'm going to pick up a little bit again on those paramecia and how they respond in an electrical field. I'll see. For right now, I'm going to call it quits. It's quite late already where I am, and I'm quite sure that's similar with where you are in some places of the world. All the best. Happy microbe hunting as always. See you around next time, and I'll order some antique slides. Thank you for your support again. Bye bye. Worms. Topic worms.